Hello everyone, my name is Nikun Sondagar and I am from India. Completed MTech in Civil Engineering and specialization in Structural Engineering. So today is our topic about the Etabs building model analysis and design by static and dynamic method. So today I want to discuss how to apply different load in building using Etabs as well as step-by-step procedures and also time history analysis and response spectrum analysis. This is the procedures and this is the steps. So first of all we are model the building, then properties defined and assigned, then seismic analysis and design, then response spectrum analysis, and last time history analysis. So this is the step-by-step procedure. So first of all, open the model, file, new model. So use built up setting with metric SI unit Indian, and this is Indian code. So here press OK. Then we will directly go with the custom grid spacing and here we will be select blank option. Press OK. Then we have to go file option, setting up project and model information. File option, project information. So we have to write everything, client name as per the requirement. We have to fill everything, then simply press OK button. So now we will go for the second step, edit option, grid data setting and add structural object. So edit option, edit story in grid data system. So we will quickly add few stories and we will modify the source stories. So this is the base, we will change it. Simply we have to write foundation, plinth, cellular floor, ground floor, F1 dash to F8. So here plinth level is 1.5 meter height, cellular floor and ground floor is 3.5 meter, and the remaining all the floor is 3 meter height. So here F8 is our master story and here is our ground floor is master story, and all are not master story. So we have to select an option each and everything, and then after say this is a master story for F8 and do it for all. So simply this is F1 to F7 is similar to F8 and the cellular floor will be similar to the ground floor and plinth will be as usual. Then simply refer, then press OK. So here we will add a new grid system. This is the G2. So number of grid in x direction is 25 meters, number of grid in y direction 25 meters, and the spacing of the grid will be 3 meter. So simply press OK and here refresh view, and you can modify. Here this is a display grid data as a coordinate. We will go with the spacing. This is a spacing whatever. If we want to delete and change, we can do it. This is 3 meter, 3.5 meter, 4 meter, 3.5 meter, 3.8 meter, 2.5 meter, and here always 0. This is a F to G spacing is 2.5 meter. Again the same way, this is 3 meter, 3.5 meter, 2.8 meter, 3.5 meter, 4.5 meter, 2.85 meter, and 4 meter. So in the same way here 0. You can see it will, if you are changing here, it will be directly show here. So then simply press OK. Refresh you, simply press OK button. So the next step is our edit grid data setting will be done. So next step is define material properties and frame properties, including column, beam, and slab. So here define material properties, add new materials, here Indian code, here concrete, and here M35 grade for only for column. So you have to simply press OK, no need to change anything. Add new materials, here we can use M20 for the beam and slab, and once again we are adding for the rebar properties. Then HYST grade 415 steel will be used, and simply press OK. Nothing will be changed, simply press OK and press OK. Then again once define section properties, delete all the remaining, add new property, concrete properties will be selected, column we have to select M35 grade of concrete, size of the column will be 450 cross 450 mm. So here we change size 450 cross 450. You can see the size also will be changed here as per the dimension. So here some notes given for the beam and column. Add torsional criteria as per the IS code is a 0.01, and add moment of inertia for column 0.7 and for beam is 0.35. So here our column, and here modified show modifier. So here we add torsional criteria 0.01. The for moment this is called, so we are using 0.7. Simply OK. Modified sorry bar, here it's our column, so HYSD, nothing will be changed. This is a diameter of bar, this is corner bar diameter, and this is a ring size. So simply press OK, OK, then OK. Add new materials, beam 600 cross 300. So simply select M20, 600 cross 300, modified. So we are selecting beam, same HYSD 415. So the so the clear cover will be 20 for the beam. Simply press OK button. Modified torsional course 0.01, 0.35, 0.35. Simply press OK. OK. So the unnecessary property will be deleted, then press OK. So now define section properties, slab sections. So we are modified, then slab 200, then we will select M20 grade of concrete will be used. 200, then press OK. OK. So the next step is assign column beam, sorry, define and diaphragm. Define diaphragm, so modified, we are using rigid diaphragm. Simply press OK. OK. The next, define, assign column beam and slab properties. So here shortcut key is available. So first of all, we'll go to the cellular floor or ground floor property. So here we select similar stories, and here quick draw beam option is available. So we will select beam 600 by 300. So simply we will select all the beams in the x and y axis. So you can see the result will be shown here. The two floor will be selected, cellular floor and ground floor. So now we have to just go first ground floor, and this is first floor. So here similar story will be again selected. So now we will quick draw beam. So we will select the beam, and the result will be so here. So now assign to slab properties. So here slab quick draw floor option will be available. Quick draw slab, this is a quick draw floor wall. So here we will select slab 200 and simply select. So you can see the two floors they will be selected. Then next, slab for the remaining portion. So all the slabs will be assigned. Simply assign for the column, quick draw column properties here. So for the apply column, first of all quick draw column, then here select column properties, then we have to select all the stories, and we have to apply for the only this part. So in the center part all the columns will be assigned to the all the floor. You can see all the columns assigned to the bottom part. So now we have to edit. Then we have to modify. Plinth will be select as a ground floor. Simply press the hit button, OK button, OK. So now we have to apply column for the remaining part. So here we select ground floor and similar stories. Don't forget to select similar stories, and then simply quick draw column. So you can see this column will be selected from only selected story. So now we have to apply the column in the all the direction. So column will be assigned. The next step is assign joint and support. So assign the fixed support, select all column at base and assign and joint and support. So now we are going down. This is the foundation level. So we have to select all the columns. All the foundation columns will be selected. So we have to simply go to, so first of all we will see the column foundation. This is not a fixed support, so we assign joint, restraint joint, fixed support, apply, select of first of all the columns, once again apply here, okay. So you can see fixed support assign. Simply the seventh step is define load pattern and add dead load, live load, wall load and floor load. So define load pattern. So we have to add, already dead load and live load will be added. So this is the wall, this is a super dead, simply add, then floor finish, sorry, floor load, then super load, add, then simply press ok button. So then define mass source, define mass source. So we have to mass source modified and simply we have to add multiply dead load, live load, wall load and floor load. So simply first of all we have to tick mark here. So for the dead load 1, for the live load is 0.5, then wall load multiplier 1, then last floor load multiplier as a 1. So simply press ok, yes, ok. So the next analysis, set load case to run and run now. Analyze, set load case to run and run now. So the analysis will be done. Then now next table view, then we have to go to display menu, show table, display menu, show table menu, click ok button. So we have to change model participation mass ratio. So now what should, this is a note, some of the ux, uv, uz, rx, ry and rz value is greater than 9, 0.9. so this is sum of x, y and z. So you can see here this is already greater than 0.9, 0.9. so if it is not, if the value sum of the rx, ry, rz near sum of uz is 0, because we are not adding anything with the z direction. If the sum will be 0.97, 0.97, 0.9, 0.96 should not be greater than 0. So what should we have to do? We have to unlock the model and simply unlock the model cache, define model cache, and we have to modify, we have to increase the maximum number of node if the value should not greater than 0.9. so simply here is 0.9, so no need to worry about that. So the now next step is provided earthquake load in EQX, EQY and EQZ direction. So simply unlock the model. Then we have to define load pattern EQX direction and EQY direction. Define load pattern. So EQX, this is the seismic load. So we have to multiply is IS. Here is the IS 1893. So we have to add simply EQY seismic 0 add. Then simply QX modified lateral load. Simply select only X direction, untick remaining all. So as per the depending on zone, we are selecting 0.24 zone 3. Soil site type is 2, importance factor is 1.5, and here is the top story to the ground floors. You can select cellular store. I will select ground floor. Then response selection factor 5. The time period automatically calculated. So simply press OK. So again modified EQY. Simply untick all the things. Select 0.24, 0.1.5 ground floor or cellular floor. We will see the ground floor. Then simply responsibility factor is 5. Simply press OK. OK. So define load pattern in X and Y direction. Again we will check this EQX and EQY. So now it will be done.